Here we have an equation, and you would think we might want to kick this off with PEMDAS in reverse, but there's something pretty different about this specific equation, and that difference is that we have an x underneath the radical and one that's not underneath the radical. So we are still going to need to keep that PEMDAS stuff in mind, but what we really want to make sure of is that this radical is isolated on one side of the equation. So as I look at this radical and I look outside of it, there's nothing to add or subtract that's outside the radical, or multiply or divide that's outside the radical. So I'm going to go ahead and get rid of this radical by squaring both sides, square, square. And when I do that, the left side becomes x squared, and the right side, the square and the square root, of course, cancel. That's the whole point, is that powers and roots undo each other. So we're left with simply 4x plus 5. And now we can't use PEMDAS in reverse here because we have an x squared term and an x term, and that means this is some kind of quadratic. So we have to rely on other tools. Typically when solving quadratics, what you want to do is you want to try to get one side equal to 0 and then see what shakes down. Everything we're doing right now, you should get a factorable quadratic. So you should try that factoring skill, and if it's really not factorable on anything you're doing currently, then you might have dropped a sign somewhere or made a small mistake. So just kind of keep that in mind. But what I'll do here is I'll subtract a 4x, I'll subtract 5 from both sides, and when I do that, I'll end up having x squared with a negative 4x minus 5 equals 0. Please notice I wrote this in standard form with the x squared term first, and then the x term, and then the constant term, because that's how I think about the factoring. When I try to factor, I want to find things that multiply to make x squared. X and X. I'd like things that multiply to make 5. So 5 and 1 are the only things that'll work. They will have opposite signs because it needs to multiply to make negative 5. And so it seems to me that if I make the 5 negative and the 1 positive, then the inner and the outer will combine to make negative 4x like they're supposed to. And of course this all still equals 0. That didn't go away. And the next thing is, if that's equal to 0 and it's this times this equals 0, then it must be the case that either x minus 5 is 0, which would mean x equals 5, or x plus 1 equals 0, which means x could equal negative 1. Now, we're not quite done yet, even though all my math is pretty good, perfect in fact. Come on. But like, we might have done all the work correctly and still got answers that don't really work. So we have to check these in the original problem. So the original problem is x is supposed to equal the square root of 4x plus 5. If I have x equal to 5, if x equals 5, this turns into 5 equals the square root of 5 times 4 plus 5. Yes, I wrote that in the wrong order. I hope you're not upset about that. 4 times 5 plus 5 is 25. The square root of 25 is 5. 5 does equal 5, like it's supposed to. So that's correct. So this is correct. So I'll keep this. If x equals negative 1, I get negative 1 equals the square root of 4 times negative 1 plus 5. So negative 1 equals 4 times negative 1 is negative 4. Negative 4 plus 5 is positive 1. The square root of 1 is 1. So I get the statement 1 equals negative 1. That's not true. 1 does not equal negative 1. So that's not an answer. So my final answer that's correct is that x is going to equal 5. Good luck with these.